I'm only here briefly to introduce Shankar Sastry, who's an outstanding engineer and scientist, he's an expert in cybersecurity, networks, embedded systems, and robotics. He got his PhD here at Cal, and he's been a driving force behind the MN from before it was actually conceived part of it. So, further ado, Shankar Sastry.
Good morning, everybody. So welcome to Berkeley. They want to be sure that they know what I'm saying, so this is what I'm saying on it. So I'd like to welcome you, first of all, and and applaud you for being admitted to this program. It is really a pretty darn selective program, and it's a new program still for us in the college. You'll hear from our benefactor and founder in a few minutes. But I want to tell you, the creation of this program has been really among the more momentous things we've done in the College of Engineering. Coleman really pushed us to do it. The College of Engineering Advisory Board had been telling us that we needed to get into this kind of professional education that is generally been something that you find in business schools, but really this is among the few engineering schools in the country that offer a technical professional Master of Engineering program. It is a fast program, it's really a pretty busy program, and every year, just about at this time, Lee with a bunch of faculty and representatives of the student body agonize about whether this really is a drink of water from a fire hydrant. This is a busy program, and whether we should slow down and ease up, and so on and so forth. And after much soul searching, it almost always comes back to, no, let's keep it the way it is. So I presume we'll be in the throes of doing this. So I want you to remember that this is going to be really no compromise on the level of technology detail that people in the workforce expect of a Berkeley master's, but at the same time, an introduction to leadership and management skills that will hold you in good stead as you go through a professional career. Just to give you a little bit about the numbers, there were 1,500 applications this year, and I think they've only about 90 of you are here, but I think we expect to have a class of about 210 or 215 this year. And let's see, that's it. Someone's flipping slides here. So that's our constituency. I'm very proud of the fact that we are almost at this. When we started the program, we really wanted to be sure that we had at least 30% women. And of its own accord, we're almost at that number. Just to tell you, college-wide statistics among the undergraduates is that the undergraduate and the PhD population is 27%. So, you're a little higher than the rest of the college. You come from 38 different countries. It's really like a mini United Nations here. It's really spectacular spread. As Lee said, when I came to Berkeley, there really was a tremendous diversity in the number of different countries that was represented. And over a period of time, that had shrunk. So I'm very pleased to see the MEng program has really been a model to draw in students from a lot of places where we weren't. So that really this having this international network of contacts, and the people that you'll see during this course of the year, and the Fung Institute will keep you all together as a cohort. These are friendships that will last a lifetime. There'll be multinational friendships. Careers nowadays are international. You'll be making these partnerships. You'll have these friendships throughout your professional career, and those are the numbers. I think that it's really quite spectacular. It's It's a pretty diverse body. You know, about a third have already had a certain amount of work experience. And, you know, so the age range also reflects the fact that some people have put in some time in, and some people are coming straight out of school. And we have the program indexed to be able to be good for both cohorts, people who are coming here directly. But of course, as you know, that these numbers don't tell the whole story. That story includes why you're here. You know, to study at Berkeley, one of the top-ranked engineering schools in the world, to be part of a dynamic ecosystem with Silicon Valley right next door, and you'll have ample opportunities to participate in this. There's an entrepreneurial ecosystem which will teach you about how to be entrepreneurial inside big companies, how to be entrepreneurial in startups, how to build teams, how to exert management skills, how to ask financial institutions for money to take your big ideas forward. And in short, you know, this program is designed to fast-track talented students like you into the workforce and to be in influential positions. And that, too, you know, we'll make no bones of it. We want you to have exceptional salary levels. You know, we want to be sure that you know, not only are you take your place in the world, but you know, you also are well compensated for it. And we've had a lot of leaders in major companies come and tell us about how they're hungry for people like you who understand the innovation process and have the people skills to lead multidisciplinary international teams spanning multiple cultures. And so I feel that the program that we've put together will prepare you to magnify the impact of technology both on societal problems as well as on the global economy. And I hope that you know, during today's visit day, you know, as you know, part of the visit day will be in terms of the Fung Institute and the leadership curriculum, but there'll be a piece of it where you'll also see what's going on in the departments. It'll give you a sense of the vitality of this overall engineering community, and I hope you'll feel reinforced about wanting to come here to Berkeley and becoming part of what is really a very exciting time to be at Berkeley, a very exciting time where we are pulling together a lot of different influences, and it's a very unique program. You know, the MEng is a pretty unique program, and so we're now in the fourth year, right? Just fifth year. This will be the fifth year, but you know, I think it was really interesting. We conducted a little bit of a listening tour to hear. But, you know, most people now say, oh, the MEng program, it's been going on 10 years, right? That's it's already gotten entrenched in the popular vernacular as the kind of program, with a really demanding curriculum, with a fantastic sort of capstone project and so on and so forth. So, you know, even though it's only in its fifth year, it's really become quite a substantive brand. So I think you'll really enjoy this. So I think I'll get off the stage and give a chance for you to hear from our founder. And so let me conclude by saying thank you all for coming, and go Bears.
Thank you very much, Dean Sastry. I now have a huge pleasure introducing someone who probably has had the biggest impact and whose vision brought us this program today. Many people have contributed to the success. You've seen the staff, Dean Sastry. But Coleman Fung had the vision. He also brought his generosity. He made his fortune in financial risk and energy market risk analysis tools. And he's been very generous in sharing that back here at Cal. He got his undergraduate degree from the IER department here and then a master's degree from across the bay. So, without further ado, and now he's on his next startup amongst his many pursuits. His next startup is Blue Doji, which is an interactive fitness company. So, thank you.
I hope this is on. Is it on? Okay. Well, good morning and welcome everyone. I'm glad you can make it to the Bay Area. I actually flew in last night, and people were telling me that it was actually raining, so that's a good thing. And more to be expected, so hopefully you make it out of here before the rain comes. I'm sure you've been bombarded with a lot of information this day and a half program, and so I'm going to keep my part of the propaganda message very short, but very to the point. I want to highlight one key element of the program. That's it. But it's a very critical element. The program is all about connection, or more accurately, help you make that connection. So Dean Sastri's already talked about how diverse the cohort is, how you may actually develop this lifelong relationship that's going to help you in whatever you do. It could be career related, it could be anything to do with the technical elements of your passion. But that connection actually goes much deeper than that. So let's talk about what's unique about the program. So as Lee mentioned, I did my master across the Bay. Again, it was one of the top programs, Master of Science, not engineering, but it was a more traditional program. You just go through classes. So for the MEng here, one of the key elements, as Lee mentioned, is the capstone. It's a very involved, so you guys are going to be very busy. I want to warn you about this. So if you want an easier program, you should go across the Bay. This is very demanding. No, but we need to filter out the people anyway. So if you want an easier program, you should take these quarters classes across the Bay. But why are we doing this? Because it's a very labor-intensive, very high-touch program. Again, it's about connection. It's connecting whatever your technical passion to the real world. It's not just about teaching you what the latest and greatest technologies are, but helping you really get a real sense of what it's like doing that kind of work. But even within that Capstone project, there's a really, really critical element we call communication. So it's very important. It's based on my own personal experience. So I hate to remind Dean Sastry about this fact. When I went to my undergraduate program here at Cal, all the engineering students were required to take technical communication class. And basically, we had to go through all sorts of training, not only in writing presentation, we were videotaped, we critique each other, we help each other to really present our idea. How do we communicate? How do we get our idea across? So I hope I'm doing a pretty good job talking to you for this few minutes. That was my most effective, useful engineering class. I know it sounds a little strange, but you may have your most brilliant ideas, but if you can't communicate that, if you can't convince whoever you're trying to convince, it will be useless. It will stay dormant until someone else pick that up and sell that idea to whoever they're trying to convince, whether it's a VC fund, investors, or your boss, or whoever. So within our Capstone project, there's a big piece of communications. So I know we are fellow engineers. We have a tendency to brush aside all the non-technical stuff. Don't. Take full advantage of it. Now, I notice we have a lot of international students. It doesn't matter whether English is your first language or not. It's not mine. But you have to practice. You have to get good at it. So I have gone through a lot of trouble getting the best resources we can get, including one of the well-known English professor from the English department here. Plus, we continue investing in this. So I want you guys to take full advantage of this. Don't just say, oh, I'm good at this. I don't need to do it. Take full advantage of it. And then that's sort of the lower level of connection. And then there's actually a bigger connection that you should also take full advantage of. So again, you're here. Why? Because Berkeley is one of the top engineering schools of the world. But Berkeley is also one of the top research university. And you compare us to other engineering schools like MIT or even Stanford. We have far deeper and wider breadth in everything we do on campus. Yes, all the good things that you hear about Berkeley, or you may not think they're all good things about student activism, about our mission, our public missions, how we serve not only California, the nation and the world, how we produce the largest volunteer cohort of Peace Corps people. So this is all part of the Berkeley DNA, how we connect to the rest of the world, the rest of the problem. Think about our research in all areas: energy, climate change, income inequalities, a lot of these social issues that's going to come up. In fact, we are part of this problem as well as the potential solutions. The constant, nonstop pace of innovation, it is in fact eliminating a lot of middle-class jobs. We don't like to talk about it, but it's a fact. I'm not saying we should stop. It will never stop. But how do we become more mindful as we innovate? Look, at the end of the day, if we innovate out our customers away and they can't afford to buy our latest innovations or gadget, that's not helping anybody. So this is what makes a Berkeley education unique. I know it's going to be extremely tight with your schedule, with your time. You won't have a lot of flexibility, but I will encourage you to make that connection within the bigger scope of the campus. Look at all the stuff that's happening at Berkeley. You are not going to find that at MIT. You're not going to find that at Stanford, but you will find that at Berkeley. So remember this. The program is about helping you make that essential connection. So it's not just about your passion in specific engineering discipline, but how to connect that to the larger world. Thank you. Why so hectic?
All right, how are we feeling? Inspired? Yeah. Yeah, all right. Well, so our next session is our part of our academic presentation. Don and Alex will be coming up, and so Don is our director of Capstone Experience, and Alex is our Capstone Integration lecturer, and they're going to go a little bit in depth about what that piece of the curriculum looks like and what it'll feel like for you.
Thank you. Thanks, Jen. And thanks both to Dean Sastry and Coleman Fung for giving a really great sort of overview about Berkeley and why you want to be at Berkeley, and Coleman's great idea or great concept of connection being the important part of this program. I'm going to drill down into details now. It's going to be mostly me. Alex won't be here, but if you have questions for him, I mean, he's here. He won't be talking, but we can bring him up for the Q&A session. I'm here to talk about the capstone. The dean talked about it. Coleman talked about it. Lee talked about it. You probably heard it a lot about how important the capstone is. It's one of the things that makes this program unique. And I want to explain to you why and drill down into the details of why. It's not just that you're doing a project. There's so many other things that revolve around this that make it such a great experience. So you've seen this already, right? By the way, this is not just a regular image. It's subliminal. If you look at it long enough, you'll want to come to Berkeley. So just keep looking at it while I'm talking. So anyways, you heard about the technical specialization. The dean talked about how important it is that you're going to get this depth. You have to have that depth that a graduate student graduating from Berkeley is going to have. Those are the courses in your concentration. The leadership curriculum, and I'll talk more about that. This is the top of the T. And the unique format that Professor Fleming brings from Harvard on the case studies. Really unique. But what brings us all together is the Capstone Project. That's why it's in the middle. It integrates the technical skills that you're going to need to do the project with the core leadership. And that's why it's unique. So it's not just that it's a project, it really is the thing that's at the core of what we're trying to do here. And I want to give you the details. Here's the details here. So a Capstone Project is E296, okay? You're going to draw from those technical electives. At its heart, the Capstone Project is a technical project. And you're going to need what you're learning in your concentration to do this project. If you're taking EECS, integrated circuits, you're going to need that information at a graduate level to do the work. At the top, we have the leadership, E271 and 272. That's the leadership course. That's the case studies, and then during the semester, the lectures. And you learn about technology strategy. You learn about intellectual property and finance and marketing and all those business type skills that both the Dean and Coleman and Lee talked about as being very important. Now, the way the capstone ties in is when you have an assignment in those, for example, a technology strategy assignment in that course, you're going to draw from your capstone project to do that assignment. You're going to look at the strategy for a company that might be in the same space as what your project is on, okay? So if you're working in robotics, you're going to look at the robotics industry, right? And you're going to look at Porter's 5 forces and how they impact what you're doing and the technology you're developing in the robotics industry. Project management, which is what I teach, you're going to develop a project plan for your capstone project. So all of these types of leadership assignments are going to draw from a capstone project. Okay? So it's at the center of it. You heard Coleman talk about the importance of technical communications and how that was really a seminal part of what he learned at Berkeley. We have a course, Capstone Integration, that's all about communications. That's what Alex runs. Okay? It's about presenting. It's about writing in different forms, short, long, informal, formal. All of that stuff is taught in that course. And the assignments you're going to do from 271 to 272 that draw on your capstone are going to manifest themselves in these assignments. You're going to be creating papers and reports and presentations. You're going to be critiquing each other, doing the peer-to-peer evaluation that Coleman talked about. And so it's all integrated, and it's all integrated around the capstone project. That's why it's important. It's not just that you're getting experiential, you're not just doing an experiential project, we're integrating with everything you're learning in the program. And that's Alex. I just want to introduce him again. You met him. You've probably met him. He answered some questions. He runs the Capstone Integration course. And I want to say this, and I'm not saying this in a bad way. He's not an engineer. So he has a degree in he has a PhD in anthropology. He comes at writing and communications from a different way than we do as engineers. And so you're going to learn about things like rhetoric and the development of arguments in a way that's going to make you good communicators. And so if you have any questions about integration, you can ask him when I'm done here, in addition to the capstone.
And if you'd like to get a head start, I'll be very happy to share some of our learning materials. My email and information about the course is on the yellow handout.
Alex has done some great innovative things this year to really make that experience such an integral part of the whole program. And we're really excited about that. Okay, so let's talk about the project, okay? Sort of why it's important. Here it is. At its heart, it's taking a new technology or looking for a new use of an existing technology to solve some industry, market, or societal need, okay? So you got technology, you got a need, and you're looking for the solution. It's a little different than a research-based project that you might do in a Master's of Science program or a PhD program, which tend to be focused more on the technology side, development of the technology, solving problems in the concept of technology. The Capstone Project, this is just as important. What is that need and understanding that need? So here's an example of a project from a couple years ago. This is a technology developed in Professor Hare's lab in the bioengineering department. It's a microfluidic electrophoresis device that can detect different types of chemicals. Okay? The Capstone team, their job was to find and develop a point-of-care device, a product, not technology, but a product that could be used for diagnosing illnesses. Okay? So part of the project, in fact, a big part of the early part of the project was finding the right disease that would be a good fit for the technology. They came up with glaucoma, which happens to be the #1 preventable cause of blindness in the world. Okay? And a lot of young children in developing countries have this illness. So they had to develop a product that could be used in this market. Okay? Low cost, low power, being able to take out to rural applications. And that was the job. So they did some work. Yeah, they did some work on the technology. Again, it's a technical project, so they had to do some work on this. They actually moved and advanced this technology a little bit. But what happened then, the need side was just as important as the technology side. Now that's one type of project, and they don't all look like that. There's a wide spectrum of projects depending on several factors. And I could go into lots of different dimensions that I've come up with, but I don't want to bore you or confuse you. Let me just tell you two things that I think are important in determining the type of project. One is how far along is the technology, okay? And that's usually measured by something called the technology readiness level. NASA, DOD, DOE, the type of people who give out money, use this sort of metric. How far along is the technology? On the one side, somebody identified a concept. If we notice in a laboratory that this phenomenon occurs, very basic. On the other side, it's a commercial product. It's ready to be sold. Everything in between is how you go from that concept to a commercial product. Laboratory testing, benchtop testing, full-scale prototypes. That's the development process. So where you fall on that will determine what kind of project you have. The second is, my cute little arrows here, has to do with the need and how the technology is connected with the need, right? In the one case, the technology pushes, we've developed this technology, now we got to go out and find the best solution, find the best need, market, problem to solve using this technology. The other one is a market opportunity pull, where you have a wide range of technologies and you don't know which one to use. You're going to go out and find the need and then pick the one you want. Okay? So let me give you an example of that in the next slide. Okay? But typically, for example, you're looking at big data. Okay? I've taught classes before in big data where that's the thing. Go find a problem that you can build a business around big data. So you go out and you spend a lot of time talking to customers, finding out what doesn't work with current products, identifying that need, and then you go to pick the technology that's going to work on that. Okay? So again, how far along is the technology and how is it being connected to the problem? Those are the two things. And that gives us this wide spectrum of projects, which we like. We like the fact that you can do lots of different things as part of the capstone. So here's, I'm going to give you an example of 3 projects this year. I call this a product design capstone. This is an example of sort of a market pull sort of project. The idea is, again, very general area, Internet of Things. Find a need, find customers, find what they want in a product, what's important to them, and then grab the technology and build a product around it, and the outcome is going to be a prototype. All right? This is one that's built around something that everybody can relate to. It's losing things. It turns out there's a big industry developing around finding things that people use, right? You saw the ads, right? Clip this to something and your smartphone can tell you where it is. Well, this thing that developing as a smart ball is to help you not lose it in the first place, okay? And it uses a platform for Internet of Things in which they built their prototypes around. So it's an example of one of these, what I call product design type of projects where the outcome is a prototype. This is more on the other end, proof of concept. This is what Professor Healy in bioengineering, okay? The idea here is he has an NSF grant, just got an NSF grant last year, and he hired an MEng team. And the idea is that when somebody has a heart attack, oftentimes one of the problems is that the damaged area isn't mechanically sound enough to continue working, okay? And that tends to have problems in terms of both mortality as well as recovery later on. So the idea is you can inject something into that zone, and that will provide a mechanical scaffolding to provide the sort of mechanical rigidity and structural integrity so that the heart can continue working and heal. And so this is a new concept, and so the students are working on more of what I would say a research side of things. They're working on doing testing in the laboratory, mechanical properties. Is it toxic? Is it not toxic? And also doing modeling, not just laboratory testing. So it's more of a moving technology along on that side where you're working with the proof of concept as opposed to really developing a product. But the students are still doing all the integration. They're still looking at the market. What's the market for post heart attack devices and products? And so this is part of their, even though it's a very research-based capstone, they're still doing all that integration in the leadership side. And this is one that's got a lot of press lately. This was in The Economist, actually, a couple weeks ago. This is Professor Agogino. Did she talk about this morning in the ME? Yeah, she did. So ME students have seen this before. So this is an idea of developing new planetary rovers for NASA, and it's based on a concept called tensegrity. These are just bars here with motors on the end connected to the other bars using cables. And by winding the motors up or down, you can change the length of the cables, and you can make it do all sort of things. You can configure it to be flat so it can be stored. You can open it up so that it can protect the payload, and you can also control it in a way so the thing actually rolls along the ground and can move. This is the second year we've done this. Next year will be the third year. Each successive team is developing this and moving it farther along the path of technology development. New prototypes, new concepts, maybe new ideas for the motors and the controllers as well. So those are just 3 examples of projects that show you sort of on the product side, on the research side, and maybe somewhere in between. Okay, so let me talk about the types of projects and who you're going to be working with. So who are you going to be advising with? So here's your capstone team, all 4 of you. So 4 we like teams of 4, 3, 4, or 5, but 4 is our ideal one. So the first type of project is one where you're going to be working directly with a faculty advisor. Typically, they're doing something in their laboratory, they're developing a technology, they're doing research in a technology, and you'll be working directly with the faculty advisor, okay? Mentorship. So one of the advantages of coming to Berkeley is you get connected to fantastic world-class researchers like our dean and others in all the departments. And you'll have that mentoring experience directly with the faculty advisor. You'll also be working with their PhD students and their postdocs and their Masters of Science students. So you get that very close connection and mentoring from the faculty advisor. But again, still doing all the integration. The second type is an industry university project. We like these as well. Actually, these are some of the best projects. With a faculty advisor, same thing, except they have an industry connection. So they may be funded. So Professor Agogino with Samsung, Professor Zodi with Siemens. Lots of other examples of research being done in connection with a company. And so not only do you get that really close mentoring experience with a world-class faculty member, you're also getting a connection to an industry person. And that backdrop, that context of how the technology relates to specific industry problems. And the last one is a completely different one. This is where the industry comes to us, the Fung Institute, and says, oh, we heard about your great Masters of Engineering program, the great capstone. We want a capstone team to work with us on our problem. Okay? They don't have a connection on campus yet. So you're typically working directly with the company, sometimes on site. You'll go down to there. If most of them are in the Valley, you'll be working with them, or somewhere in Berkeley and Oakland. You'll be going to their location to work maybe once a week. So we typically will then connect you with a faculty member. You have to have a connection on campus, and that's usually myself or Professor Fleming who become the faculty liaison. Okay, so this year I have 6 projects that are of this form, and Professor Fleming has 3. Okay? This is a connection. This is a project where we get very close interaction with industry and the types of problems industry are worried about. So it's industry, faculty, university, industry, and industry or virtual internship. And just so that you know, you got this list of projects, right? Remember the list of projects at the end of the sheet that Joyce sent to you? If it says faculty proposed project, but there's no industry person listed, that's a university project. If it says faculty suggested, but it has a industry name, that's a university industry. And if it says industry proposed, then it's an industry project. Okay? So that's how you can tell. So if you're looking and you want to say, oh, this is an interesting project, I wonder what kind of people I'll be working with, that will tell you. And here's the people we're working with this year. Big names like Cisco and Google and Applied Materials and NASA, but also some small startups like Vehicle Data Science and Transsense in the middle, which is a startup that was founded just recently by an MEng student who graduated last year, who came back to us and said, I want an MEng team to help me work on this product I'm developing. And so a full range, depending on what sort of experience you want to get. Okay, very briefly, a lot of people asked me yesterday, how do we pick the project? Okay, here's the timeline. Here's where we are now. We've given you the list of projects. That's not the final list. It's going to probably be reduced a little bit. We'll add some projects, but it gives you a sense of what types of projects. Once you're in the program, once you look at that gear enough and you're convinced that you want to come here, right? Gear. Then in July, we'll tell you the full proposals. This is like 1.5-page proposals for each project. So you can really drill down into the details. What kind of skills are they looking for? What kind of objectives do they have? What am I going to do technically? Who am I going to be working with? We'll give you those in July. Okay? You'll have all through July until you come for boot camp to review those, maybe contact a faculty member, get information. Then at boot camp, every day at lunch and sometimes at dinner, we'll have information sessions. The faculty, the industry advisors will pitch to you, quick pitches, here's what my project's about. Then they'll split up into different rooms or areas, and you can go talk to them directly and ask them questions. So again, information gathering. You can find out not only what the project's about, but who you'll be working with for an advisor. Then after that's done, at the end of boot camp, we run an open market. It's just like getting a job, okay? You write a cover letter, you submit a resume for 4 projects, I think. Is that what we did last year? 3 projects. And the faculty advisor, the industry advisor reviews your resume, decides who they want to hire. They make an offer. You get multiple offers. You accept the offer you want. It's just like getting a job, okay? That's how it's run. Takes about a week to 10 days to do that, maybe 2 weeks, and by the middle of September, you guys are on teams and ready to go, and you're off and running. So that's the process, okay? It's an open market, just like getting a job. Now, this isn't true for EECS. EECS does more of a matching. They have their own projects, and you pick the projects, I think, that you want, and then they try and do the matching themselves, okay? We don't do that anymore because once we grew beyond a certain number, it's too many degrees of freedom. And we
want to show a little example of a command economy.
Yeah, right. Yeah. Thank you. And I want to pitch one project for next year, and I think Coleman might even want to say a few words about this. This came from us from the Office of the Chancellor. This is a problem that they have. They want to create a sort of single point, place where students can find information. It's all over the place now, right? If you're a student here, you go to all these different places to find information. They want a single app that they call the Student Wellness App, which has information on academics, on health, on social life, all the different things you're going to need as part of your life here at Berkeley. But in addition to that, a recommendation system built into that. Some data analytics to help you personally find out the best things you should be doing to become better in academics, to be healthier, to have a better social life. So as I said, if you work on this project, you'll be working closely with the chief of staff for the chancellor. It's an opportunity to really leave something behind at Berkeley. And we're going to run it different than any other capstone project. Every other capstone project is one project, one team. We're going to have multiple teams. We're going to have multiple teams competing to come up with the best solution, right? And the best solution, we hope, will be the one that gets implemented, will be the one that students will be using at Berkeley for years to come, okay? So we're going to run it like the challenge courses I've run before in other places. There'll be a product development aspect of this. Again, talking to the students on campus, finding out what their needs are, what sort of interfaces they want, what their experience is that they want, but also some algorithm development, some data science behind developing the recommendation system that could be used for this. So I think this is a very exciting project. We're really looking forward to this. And when you come here in August, one of the info sessions will be a pitch of that, and we'll give you more of the ideas of that. Coleman, you want to say a few words about that?
So the Chancellor and I have been, as you know, my startup 2.0 is in the space of wellness. So we've been talking about how we can actually make a difference in not just the MN's life, but undergraduates, everybody, which is a much bigger population. And so we really want, this is not a unique problem at Berkeley. Basically, at every university, their system's been developing over time, so a lot of different systems that they need to pull all the information. And so basically, how do we solve that? As Don mentioned, there's an element of big data. So it's going to be very exciting, but what he didn't say is actually the winning team, if you have a really good proposal, the chancellor at Twisted Arm will actually give you the seed money to get your startup going. So this is the benefit. Again, this is the benefit of the connection.
That's good. See, I was thinking that it was a startup.
Yeah, that's a startup twice.
It's a startup because it wouldn't just be used at Berkeley. The idea is to sell to other universities as well. Pearl is...
This is my new assistant.
Okay, great. Last thing, and then I'll take some questions and answers. So what's the value of the capstone? Well, you can see, I hope, that there's a lot of things that are of value of the capstone. There's the team experience, which we think is really important. That's why we do it in teams. There's the value of applying your technical knowledge, right? That taking things you learn in the classroom and doing a hands-on project to actually get some experience with the knowledge and skills you're developing. There's the integration with the leadership curriculum and all the opportunities to talk and write about it through the capstone integration. But in my mind, the real value of any sort of project like this, and particularly the one here, is the value of learning how to deal with obstacles. Around here, people will talk about failure. It's all about failure, so learning how to fail fast and recover. I like to think about it as just understanding how to deal with obstacles and getting around obstacles. Because no project is going to start at point A and go linearly to point B, which is where you think you're going to end up. There's always going to be issues. It could be a technology issue, okay? Oh, you know what? That compound is toxic. We can't use it. Okay, what are we going to do? It could be a teaming issue, okay? Team dynamics. It could be an issue with the faculty member or the industry advisor, okay? You're not getting the data you need. You're supposed to get the data, but they're not giving it to you. There's lots of different issues that come up, right? And this is not unique to Capstone Project. When you go in industry and work on projects, there's always things that come up, always issues to deal with. By the way, has anybody read the book The Martian yet by Andy Weir? One. It's a great book. It's a book that, in my mind, is the epitome of what it's like to be an engineer and to deal with this problem. Obstacles thrown at this person day and night, but as an engineer, figuring out ways to solve them and get around them. Okay? And what's great about it is you get to learn this within the scaffolding and the framework of our program, with resources like Alex and myself and Lee and everybody else to help you try and figure out, and your advisors, to how to navigate it, so when you do get out and you go and work on a project in industry, you'll say, oh, you know what? That happened to me when I was at Berkeley, and here's how we solved it. Okay, some FAQs real quickly. How many students are on a capstone team? 4. We'll do 3 to 5. Can I work on a capstone by myself? No, because 1 doesn't equal 3 or 4. And that's because we want the team experience. We want you to get the team experience. Can I use my own idea for a capstone project? And again, short answer, no. We've done a lot of work to try and develop these projects that give you the sort of experience we want. And so we want you to pick one of these. Now, if you're working for a company, I've talked with a couple of people who work for companies who've said to me, oh, you know, the company I work for may want to do a project. That's different, okay? And if you have some ideas through the company you've worked for, then come to me and we'll see if we can work something out, okay? Oops. How do I get more information? You can ask me. Okay, I can give you information on the capstones. The faculty members' names are listed in there. So Dean's not going to hear me say this, but you could contact them. Absolutely. Contact them and ask them specifically about the project. Tell them, especially if you're going to do it in the next 2 weeks, tell them, I'm thinking about coming to Berkeley. I want some more information on your project to help me make my decision. They'll be more than happy to do that. What if I can't get hired for a capstone? It's not going to happen. It's never happened. It won't. 85 to 95% of the students get hired in the first round, and we get everybody else in projects within a week after that. So it's not a problem. And besides, everybody's going to want to go to our challenged one anyway. So we're going to take multiple teams for that. We're going to run up to 5 teams on that project. So finally, can EECS students work on non-EECS project? The answer is yes. When you get a list of projects that you can choose from for the EECS students, there will be a subset of those that are the projects that come out of FUNG that you will be able to work on. I don't know, did Antonio talk about that? So Antonio was one of the people who decided to do a project outside of EECS, and he's actually working on the Transcends project. So there will be some opportunities. I think out of like 60 students, only 3 students chose to come out of EECS because the projects in EECS are great, and everybody found the sort of thing that they were looking for in there. So, but if you want more of an interdisciplinary experience, there will be some projects to do that as well. All right. That's all I have. And Alex and I would be happy to answer some questions. We've got a few minutes before we're done.
Any questions?
Thank you. So I got questions. So the Chankelins app, is that right? It's called Chankelins, right? Oh, the startup that
yeah,
Transcends. Okay, yeah. Sorry. So the Transcends project, is that initially listed as a capstone project?
It didn't start out as a capstone project. It was a project. It was actually something that the student was doing outside of his capstone project. Okay, he actually went through, I think, the Lean Startup class through Haas Business School. Also went into the Big Ideas competition at Berkeley. And from there, got enough leverage and a little bit of startup money to actually go forward. So it didn't start as a capstone project. So it just shows you that you have opportunities beyond just what you're doing in the program to try and build, again, connections with people on campus to, if you have entrepreneurial tendencies. So, yeah.
Okay, thank you.
What? The students from the program, but it wasn't a capstone project from the program that they used, right? And that company's been featured on the Berkeley and the university website within the last couple of months.
I'm interested in the nuclear engineering MEng program. So what I want to know is how well connected Berkeley is here with the nuclear industry, like what partners you have or are thinking about teaming up with in the near future.
I'm not the person to answer the question. Maybe the dean can answer that question.
So, nuclear engineering is going through a bit of a resurgence. And
absolutely.
They are, this particular sweet spot has been small footprint nuclear reactors. Small footprint doesn't mean super small. It's truck size is what we're talking about. Big rig size, I don't know. And I think that they have established connection with and with non-proliferation also included in this. So those, I think they have really, I think a lot of their design activities, and actually Per Peterson, who's the Executive Associate Dean, was talking about how they're going to start having this year, partly for MN students in nuclear engineering, a design innovation lab for this new generation of reactors. And certainly there's a huge market for them, Westinghouse, Areva, a lot of interest in China, because China, of course, is going to have a lot of its commercial power. So they are really highlighting design in the building of new reactors. And your question's a good one, because in the past, small reactors were the kinds that went into subs. Whereas, now you're really going to be thinking about subs and ships, but they're really going to be thinking about nuclear reactors for energy generation. So that I think it sounds really exciting to me. What they're trying to do.
Yeah. So there's definitely like a resurgence in the industry, and like all those companies you mentioned, Westinghouse, new ones like NuScale.
Yeah.
Have you guys connected with any of these guys?
Yes, so they are, and they had. So each department. The departments have their own ecosystem of industrial advisory boards and so on and so forth, and they have. So you have a foot in the Fung Institute, and the Fung Institute takes care of you. But there's also a departmental piece, and so you get integrated into that ecosystem as well. So Don,
I got my microphone. Thank you very much. I just want to also say that I know that the project that Per Peterson is working on, he is connecting with Westinghouse people, because I've been involved with emails going back and forth between Westinghouse engineers and Per about what their involvement might be. So on that project, you will definitely be interacting with people from Westinghouse. It's sort of a university industry collaboration with Westinghouse on that.
Okay. Right,
and they're very interested in working with the MN students on this. So.
And they recognize that you asked a question about industry connections, but from my perspective, I want to emphasize how awesome these projects are. So last year, the project on small nuclear reactors was one of the best projects, one of the best teams. This year, the project on nuclear waste.
Interim storage, which is a huge topic right now, given the fact that they're not going to be going forward with Yucca Valley. So where do you put it in the interim? So they actually had a team doing a design of an interim storage facility. As part of that.
So, if you care about social impact, if you want to demonstrate your involvement in broader problems, this is the place to do it, because you'll have the kind of teammates who are so dedicated and so enthusiastic about doing this kind of work. So these are, I can't have favorite projects, but I very much have a very, very special spot for those.
Thank you.
Okay.
Anything?